When we ask an AI to think step by step, something remarkable happens. Accuracy on complex reasoning tasks improves dramatically. Chain of thought prompting elicits intermediate reasoning steps from a model before it produces its final answer. In the next few minutes, we will explore why this technique works, the key variants and extensions, and where it delivers the greatest practical value. Chain of thought is one of the most impactful prompting techniques discovered in recent AI research. Let us get started. Let us understand why making AI show its work produces dramatically better results on complex tasks. Chain of thought prompting works by instructing the model to produce explicit intermediate reasoning steps, transforming a single-step prediction into a structured reasoning process. Let us define the core vocabulary for chain of thought prompting and its extensions. The reasoning chain is the sequence of intermediate steps the model produces as it works through a problem before stating its final answer. Making this chain explicit serves two critical purposes. First, it improves accuracy by giving the model structured space to handle each subproblem before moving to the next, reducing the compounding of errors that occurs in direct answer generation. Second, it makes the model's logic auditable. A human reviewer can follow the chain to identify exactly where a reasoning error occurred, which is essential for high-stakes applications where AI outputs inform consequential decisions. Self-consistency addresses a key limitation of single-chain reasoning. Any one chain of thought may follow an incorrect path, even when the model generally knows how to solve the problem. By generating multiple chains independently and then aggregating their conclusions, we reduce the impact of any single incorrect reasoning path. Self-consistency sampling with 5 to 20 chains has been shown to substantially improve performance on mathematical reasoning benchmarks. The aggregation approach is analogous to an ensemble in traditional machine learning, Multiple independent estimates are more reliable than any single estimate alone. Zero-shot chain of thought is the accessible entry point into this technique. Rather than constructing elaborate few-shot examples with complete reasoning chains, which requires domain expertise and significant effort, we simply append a brief reasoning instruction to the prompt. The phrase, "think step by step," was popularized by research from Google Brain that demonstrated its effectiveness across a wide range of reasoning tasks without any task-specific examples. This makes zero-shot COT the first thing we should try when a model is producing incorrect answers on complex multi-step problems. Tree of thought extends chain of thought from a linear sequence into a branching search process. Rather than following a single reasoning path to completion, the model explores multiple possible next steps at each decision point, evaluates their promise, and pursues the most productive branches while pruning less promising ones. This deliberate search is more computationally expensive than standard chain of thought, but dramatically improves performance on tasks requiring creative problem-solving, complex planning, or exhaustive exploration of possibilities where the first reasoning path attempted may not be the best one. Now let us see where chain of thought prompting delivers the most significant improvements in real applications. Chain of thought prompting is most valuable in domains where mistakes in intermediate steps lead to significant downstream errors or where reasoning transparency is required. Let us close with the 4 most important lessons from this overview of chain of thought prompting. To explore more key concepts in generative AI, check the link in the description. If you found this helpful, please like and subscribe. Thank you for watching. If you found this helpful, please like and subscribe. See you in the next video.